Today I will discuss pressure measurement by using YouTube manometer. Now here one gas container is there, and inside the gas container, just consider Pg is the pressure. Now we are going to measure Pg, the gas pressure inside the container, by using YouTube manometer. Now here the container is connected with YouTube manometer, and the pressure exerted by the gas molecule acting on the liquid, so that is called manometric liquid, and pushed that manometric liquid in the left hand side, and because of that the manometric liquid will rise up in the right hand side. Just consider the Pg is the rho g is the gas density, and height from the center of the container to the gas liquid interface is hg, and manometric liquid density is rho m, and and height difference means how much manometric liquid rise up in the right hand limb, so that is hm, and that manometer one end is right hand end is closed, so no external pressure is exerted on that right hand limb. Now how do we calculate the pressure inside the container? Means how do you calculate Pg by using YouTube manometer? Now here so we are going to step by step. First, step 1, so draw a horizontal reference line from two fluid interface. Now here gas is one fluid and manometric liquid is there, so this is the gas liquid interface. From this gas liquid interface, first draw horizontal reference line from two fluid interface. Okay, so here x and x dash is the horizontal reference line. Next, step 2, then calculate pressure acting on the same liquid at the same reference line. Means here in A point we have to calculate the pressure, as well as we have to calculate the pressure at point B. Now step 3, so pressure acting on the same fluid. Pressure acting on the same fluid means pressure acting on the manometric liquid in the same reference line will be the same. Means whatever pressure acting on that left hand side, means A point, and if that is equal to pressure acting on that right hand side, B point. Here P and PB are the same, as pressure exerted the same fluid as same reference line, so we can write PA is equal to PV. Now step number 4, calculate pressure at point A. Now how do you calculate pressure at point A? Now here gas pressure is Pg, right? Gas pressure is Pg, and height difference is hg, means from the reference line to that center of the container, so that is hg, and here that gas density is rho g, and we know that P is equal to h, rho and g. So from this formula we can easily calculate, because we know the height, we know the gas density, so we can easily calculate what will be the pressure at point A. So point A will be, so pressure already exerted by the gas, so that is Pg, so Pg plus hg into rho g into g. Hg is the height of that gas, okay, from the reference line to the center of the container, and rho g is the gas density into g. G is acceleration due to gravity. So now here we already calculate pressure at point A. Now next step, calculate pressure at point B. Point B, so here no pressure is no external pressure is exerted on that right hand limb, so we can write what will be the pressure at point B. So that is nothing but, so from that rise of the manometric liquid is hm from the reference line, so we can easily calculate the pressure at point B, hm into rho m into g. Hm is the height difference, means rise of the manometric liquid, rho m is the density of the manometric fluid, and g acceleration due to gravity. Now we know that Pa is equal to Pb, because pressure acting on the same fluid at same reference line, that will be same, so Pa is equal to Pv. So you can write Pa is equal to Pg plus Hg rho g into g is equal to Pv, that is Hm, rho m and into g. Okay, now we can reorganize and we will get Pg is equal to Hg rho g in g in is equal to Hm rho m into g. Now we consider, so that is that, then we can again, so here we are going to calculate Pg. So Pg will be rho m Hm rho m into g minus Hg rho g into g. Now the consider, because gas density is very low, so gas, if you consider gas density is negligible, so this term will be go out, means this term will not be there. So we can easily calculate that Pg will be Hm rho m into g. Okay, so now from the C2 manometer, so if you know the height difference, means how much manometric liquid is rise in the right limb from the reference line. So if you know that, we can easily calculate what will be the gas pressure inside the container. We can easily calculate. So Pg will be Hm rho m in g. So Hm is the height difference, rho m is the manometric liquid, into g is acceleration due to gravity. So rho g is equal to Hm rho m into g. So that way you can easily calculate how much pressure inside the container, that will be Hm rho m into g. Now next, now consider some liquid is there. Liquid is there in the container, and we are going to calculate, means here how do you calculate the pressure inside the container. So now here the liquid pressure is PL, so that is acting, that pressure is acting, the pressure is exerted on the manometric liquid, so that is rho m, blue color. So as PL is very high, so again that liquid will push to the manometric liquid, and that will be rise in the right hand side, and that rise is Hm. Now how do you calculate the pressure PL? Okay, so here that is the similar for earlier. So step again, draw horizontal reference line from the two fluid interface. So this is the two fluid interface. From here we have to draw the horizontal line, so that is actually called XX reference line. Now second, calculate pressure acting on the same liquid at the same reference line. Step number 3, pressure acting on the same fluid at same reference line will be the same, so it means PA is equal to PV. Now how do you calculate pressure at point A? So pressure at point A, so this is actually L. Okay, so that is PL plus that height from center of the container to the gas liquid interface, that is HL. So we can write PL plus HL rho L into G. Rho L is the liquid density, and then calculate pressure at point V. So that is PV. PV is nothing but HM. HM is the height rise of the liquid from reference line, so that is HM. HM into rho m into G. So now we know that PA is equal to PV, so we can write PA is equal to PL HL into rho L into G is equal to PV HM rho m into G. Now from here you can easily write PL plus HL into rho L into G is equal to HM rho m into G. So from here we can easily write PL is HM rho m into G minus HL rho L into G. So HM is the rise of liquid from the reference line, okay, and rho m is the manometric liquid density, G is the acceleration due to gravity. HL is the height from center of the container to the gas liquid interface, or you can say that reference line. Rho L is the liquid density, and G is the acceleration due to gravity. So from that we can easily calculate what is the pressure at liquid container. So that is PL is equal to HM rho m G minus HL rho L into G. Then so now again here, so that right arm limb is closed, so as there is no external pressure is exerted on that right hand limb, okay, or right hand. Now next, if that right hand limb of the YouTube manometer is open, okay, now so what will happen? So P atmospheric pressure will act on the liquid. So now here if it is open to the atmosphere, so now we have to consider that P atmospheric pressure. Now similarly, whatever we did in the earlier, similar way we can do that. So now at horizontal reference line, so PA is equal to PV. Now we can calculate PA. PA is equal to PG plus HG rho G into G, like previous slide, and PV is equal to HM rho m into G. Now PATM you have to consider because it is open to atmosphere, means atmospheric pressure exerted on the manometric liquid. Now we know that PA is equal to PV, so we can write all these things and we'll get PG plus HG rho G is equal to HM rho m into G. Now if we reorganize, so PG minus PATM, HM plus rho m into G, HM into rho m into G minus HG into rho G into G. Now again, if gas density is negligible, so this term will be cancelled out. So we will get Pg minus PATM is equal to HM into rho m into G. So that is actually called gauge pressure or gauge pressure. Gauge pressure, right? And PG is actually absolute pressure. So absolute pressure is PG is absolute pressure. Absolute pressure. Okay. So absolute pressure is equal to PATM plus gauge pressure. Now similarly, if the container has liquid and that this other end of that manometer, so that is open to atmosphere. Okay, and again that ATM pressure is acting on the right hand limb of the U2 manometer. Now how do you calculate the pressure PL? So same thing. So first we have to draw the reference line, and then PA is equal to PB, and first we have to calculate PA. PA is nothing but PL plus HL rho L into G, and PV is nothing but HM into rho M into G. Now plus, obviously, plus PATM. Okay, and then we can we know that in the reference line, same means pressure acting on the same fluid at same reference line will be the same. So PA is equal to PB, PA is equal to PL plus HL plus HL into rho L into G is equal to PV is equal to HM rho M into G plus PATM. Now if we reorganize, okay, ultimately we will get PL minus PATM is equal to HM rho mg minus HL rho L into G. So that way we can easily calculate the pressure. So PL again, this is the absolute pressure, and this is atmospheric pressure, and this is the gauge pressure. Now another example. Now here one fluid is there in the container. So what will happen, as PF is not that much, what will happen? So if it is less than atmospheric pressure, so manometric liquid will rise up in that left hand side. Now how do you calculate what will be the pressure inside the container? Now here again the right hand side, the U2 manometer is open to the atmospheric, so atmospheric pressure will acting on the manometric liquid again. So first we have to do the we have to draw the horizontal line. So here that gas and liquid interface from there here, so first I have to draw the horizontal line. Again there is also a horizontal line. Okay, so here we are taking that reference line, and from that in the same liquid, so consider that pressure acting on the same fluid in the same reference line. So here if we consider this is the reference line, so there will be no manometric liquid, so we cannot consider as a reference line. So a reference line will be here. Pressure acting on the same fluid, the same reference line will be the same. Here PA and PV are the same as pressure exerted same fluid as reference line, so that is PA is equal to PV. Now we have to calculate PA. PA is nothing but PF plus, because of this liquid, this fluid, so there will be another pressure, so that is hf rho f into g, and because of this rise of that rise of liquid from the reference line, so that we have to calculate again, so that is hm rho m into g. And what will be the pressure at this point? So only atmospheric pressure is acting on that right hand side, so that will be pv is equal to pt in the patm. Now we know pa is equal to pv, so pa is equal to pf plus hl into rho l into g plus hm into rho m into g is equal to patm. So from that, if we reorganize, so patm minus pf is equal to, because patm pressure is higher than pf, pf is the vacuum pressure, because of that that manometric liquid rise up in the left hand side. So patm minus pf is equal to hl into rho l into g plus hm into rho m into g. So you can write like that, patm minus pf is equal to hm rho m g plus hm rho f into g. So that is, we can easily calculate, that is vacuum pressure. Okay, next another example. So now very interesting, so liquid is actually moving in a pipe, liquid is flowing in a pipe. Now we have to calculate what will be the pressure if we take 2 points, so point 1 and point 2, and if we connect U2 manometer, what will be the pressure difference between P1 and P2. Okay, now liquid is flowing, so in that upstream means here obviously pressure will be higher, and that will act on the manometric liquid, and manometric liquid will be just pushed down, and the right hand side manometric liquid will rise up. Again in the point 2 also that liquid is acting. Now from here we have to calculate what will be the pressure difference. Now again, so that two liquid interface, so we have to two fluid interface or two liquid interface, we have to draw the first draw the horizontal line, and then calculate what will be the pressure at point A and pressure at point B. So pressure point A, so that is P1, and that trapping, so we are taking two trapping 2 point, so P1 plus because of some liquid is there, because of that liquid there will be some pressure, so that is hf rho f. Hf is the height of that liquid, and then rho f is the density of the fluid into g, so that is the pressure at point A. Now pressure at point B, so that is pb plus pb is equal to p2, and then because of this liquid, this liquid height is hf minus hm, so hf minus hm into rho f into g plus hm rho m into g. Okay, now we know that pressure acting on the same fluid as the same reference line will be the same. Here p and pv are the same as pressure exerted the same fluid as same reference line. So now we can write pa is equal to pa is equal to pv. If you write that p1 hf rho f into g is equal to p2 hm minus hm into rho f into g hm into rho m into g. Now if we reorganize and if we open up everything, so here hf rho f and g will be cancelled out from the both side. So finally we have p1 minus p2 is equal to minus hm rho f g plus hm into rho m into g. Now ultimately p1 minus p2 will be hm rho m minus rho f into g. Okay, so that is the pressure difference in 2 points. So remember p1 minus p2 is equal to hm. Hm is the that height difference of manometric liquid, and then that density difference between manometric liquid and that fluid which is flowing inside the pipe, that difference into g. Okay, so that will be the pressure difference in the 2 point. So if we want to measure pressure difference in the 2 point, so we can use this equation. If we know that hm means height difference of that manometric fluid, and if we know the density difference, and then we can easily calculate what will be the pressure difference at 2 points. That's it.